Hi, welcome back to the second part of the first podcast. Already we talked about the area of squares. This time we're going to talk about the perimeter of rectangles and the area of rectangles as well. Now, a little bit different than squares, rectangles are still a four-sided figure in which opposite sides are congruent to each other. So what we're going to do is we're going to call this side B and we're going to call this side H. Now, I know sometimes some teachers use L and W for rectangles, but to kind of keep things as simple as possible throughout this unit, I'm going to refer to them as B and H. Again, to find the perimeter of a rectangle, what we need to do is add the four sides together. So we're looking at B plus H plus B plus H. So the formula in a simplified form would be 2 times B plus 2 times H, where B is one side of your rectangle and H is the other. To find the area of a rectangle, we are just going to multiply the two dimensions together. I refer to one as the base, and I will refer to one as the height. So when we say what is the formula for the area of a rectangle, we are going to say B times H, which is base times height. So what we're going to do is we're going to go through some examples in terms of how to solve for the area of rectangles. Let's take a look at the first example. When you're dealing with rectangles and trying to find the area to these figures, you need two dimensions. You need the base and you need the height. As you can see in this case, we are given one of the dimensions, but we are not given the other. Now we need to remember that in these corners are right angles. So a lot of times what we need to deal with are right triangles being formed by the two sides, the diagonal, and then we need to figure out what do we need to use to help us figure this out. It can be Pythagorean theorem, it could be 30, 60, 90s, it can be trigonometry. So in this case here, knowing that I have two of my sides given to me, we can just use a little Pythagorean theorem to help me figure out this value of this side here. So over here I'm going to write A is equal to B times H. Right now I know one of my dimensions is 15. I better figure out this second dimension. So by using the Pythagorean theorem, we got x squared plus the other leg squared, and that's equal to your hypotenuse squared. So we're going to end up with some pretty big numbers here. So 15 squared is 225. 39 squared, even I need to use a calculator on that one. 39 squared turns out to be 1521. Solving for the x squared, subtract 225 from both sides. And then you get x squared to equal, now we need to subtract 225 here, and we get 1296, square root, and we get x to be positive and negative. Always remember the positive and negative. And we get an answer of 36. Again, we are dealing with the side of a rectangle, so it's going to be the positive one only. So 36 is the other dimension, and again, all I need to do is take my two dimensions of 15 and 16, multiply them together. So I got 15 times 36, and we get a nice answer of 540. Again, your units should be squared. They don't tell me what they are, so we're just going to go units squared. This is the general form there. Okay. Now, if you knew your family members, you can also figure out that this was 36 because this is one of the 5, 12, 13 right triangles. Let's take a look at the next example. All right, so find the area to the given rectangle. We need that dimension, we need that dimension. One thing you may look at is opposite sides are congruent. Maybe you give this one, you don't, or maybe you have this one and you don't. So there, we need to find both of the sides. So again, one thing you want to take a look at is what type of triangle do you have when you have your two dimensions and the diagonal drawn in. In this case, we actually end up with a 30, 60, 90 triangle. And then we need to remember how the three sides of a 30, 60, 90 relate to each other. Across from the 30 was x, across from the right angle was 2x, and across from the 60 was x root 3. So what we need to do is take the one side that's given to me, which was the 48, set it equal to 2x, and then solve for x. Dividing both sides by 2, x turns out to be 24. So wherever I see an x, I can replace it with 24. This side is just x, this side is 24. This side is x root 3, this side is 24 root 3. So what is the formula for the area of a rectangle? It is base times height. Your base in this case is 24 root 3, and then your height is 24. Now, if we want to get an exact answer, what we can do is multiply the two 24s together. So I take my calculator, 24 times 24, and you get an answer of 576 square root 3. And again, the units should be squared. This right here is an exact answer. If I wanted a decimal approximation, all I need to do is take 576, multiply it by the square root of 3, and we get an answer of 997.66. 997.66 units squared. So again, exact answer, decimal approximation. Let's take a look at my next example. Again, we are dealing with a rectangle. Looking for my two dimensions, I have neither one. So the first thing you want to take a look at is using the diagonal and the two dimensions, knowing that this is a right angle. What do we have here? Now we are given that this is a 52-degree angle. This one we're going to have to use trigonometry. So we need to remember the word SOHCAHTOA. SOHCAHTOA. So what we did is we circled this angle and we labeled opposite, hypotenuse, adjacent. So what we're looking for is this piece I will call X and this piece I will call Y. So let's try to find X first. So if we're trying to find X, which is the opposite, we are given the hypotenuse, so that would be the SO. So I have sine of 52 degrees is equal to your opposite side over your hypotenuse. In this case, all I need to do is multiply both sides by 16 to give me an approximate value for my X. First thing you want to take a look at is, are you in the right mode? MODE, third line, degree, we are good to go. And you would hit 16 times sine 52. And you want to go to two decimal places. So we're looking at 12.61. 12.61. So my X, this piece, is 12.61. That is one of my dimensions. So right now I have the area of the rectangle to be 12.61 times something else. Now, I need to find my adjacent. Again, I'm going to use my hypotenuse. So the A and the H is the cosine. So I have cosine of 52, and that's going to be equal to the adjacent side over your hypotenuse. So I have cosine of 52 is y over 16. Again, when the variable is on the top, we just multiply both sides by 16. These will cancel each other, and you get y to be approximately, calculator time, 16 times the cosine of 52, and you get an answer of, to two decimal places, 9.85 approximately. So this piece is 9.85. 9.85 is my other dimension. Now we're going to get an answer when I multiply those two numbers together. So I got 12.61 times 9.85. And again, we're going to round the two decimal places. So we're looking at 124.21. And again, we want units squared. And that is my final answer for that problem there. Okay, so there we had to use a little trigonometry. Okay, let's take a look at the next example. It says the area of a rectangle is 1,344 inches squared, and the ratio of the sides is 3 to 7. Find the dimensions of this rectangle. Here, we're going to need a little picture. So what do we have? We are given that the area is 1344. We know the area is base times height, so let's take a look at how we can use the ratio of 3 to 7. So if the two sides are in the ratio of 3 to 7, they can't be 3 and 7 because 3 times 7 is not that number. So if you remember, what we did is we included the variable x when we labeled our sides. So the area, which is base times height, so if I take these two terms, multiply them together, 3x times 7x, that should equal what the area is, which is 1344. 3 times 7 is 21. X times x is x squared, is equal to 1344. Now I just have to divide both sides by 21, and I get x squared to equal, calculator time, 1344 divided by 21, and I get 64. Now I can take the square root of both sides, and I get x to be positive and negative 8. Again, we cannot use the negative one because it would give us a negative length. So x is going to be 8. So this side here is going to be 3 times 8, which is 24. And we're dealing with inches. And then this side would be 7 times 8, which is 56 inches. One thing you can do to check to see if you did it correctly is take 24, multiply by 56, and it should be 1344. It is, so we're probably in pretty good shape. Now the next type of question is one in which you have an odd figure. And what you need to do is figure out a way to find the area of this bounded region. There's two ways of doing it. The first way is if you were divided into portions in which you can figure out each of these areas separately and then add them together. Okay, I call this split and then add. So let's find the area to the first piece. So the first piece is over here. It has a dimension of 15 and 20. So 20 times 15 can be and should be 300. Find the area to my second piece. Well, if this height is 15, then that means this piece is 15. Now down here from this side to this side it is 100. From here to there is 20. That's another 70 for a total of 90. So this piece has to be 10. 15 times 10, $1.50. And then last but not least, what's my third piece? So we need to kind of do some thinking. I know this piece is 100. What I need to do is figure out what is the height from here to there. Well, from here to the bottom is 50. From here to here is 15. So that means this piece is going to be 50 minus 15, which is 35. 100 times 35 is 3,500. So now all I need to do is add this, and that together to get the area of the whole piece. So I got 300, 150, 3,500. If you need a calculator, let's use it. We got 300 plus 150 plus 3,500, and you get 3,950. So that is one way to figure out the area of this bounded region. Let's find another way. So we're looking at the same figure, and this way is to create a whole piece first and then subtract away what's not really there. So if I was to connect from this top to this top, I have created a big rectangle. So the area of the whole piece can be found by 100 times 50. So that's 5,000. But this part of the picture does not really exist. So I need to subtract that away. So the area of that piece is found by 15 times 70. Get a calculator on that one. 15 times 70, and you get an answer of 1,050. So then, if I take the area of the whole piece, subtract the piece that's not there, lo and behold, it matches exactly what we got on the top part. So which method you use, it depends on what you feel more comfortable using. If you want to cut it up into pieces, great. If you want to make one whole piece and then subtract away, that's fine as well. That is the rectangles and how to find the area with the different scenarios. Again, if you are having troubles with this stuff, make sure you come in the morning and ask me questions.